Hello everyone again and welcome to machine learning tips. So today we are going to be looking at some key concepts in machine learning and how we can handle them as we move to most of these real world applications. So some of these key concepts are what we call bias and variance. I've been mentioning this a lot, saying that the error that we had in the target function for the regression problem we saw yesterday is made up of what we call variance and bias and the irreducible error. So these are two very crucial terms in machine learning because if we handle these two terms very well, then we can build machine learning models that are very accurate in making what decisions. The first term here is what we call bias. Bias can be defined as the error introduced by approximating a real world problem by using what a very simplified model, or it can also be defined as a simplifying assumption made to learn the target function. By the target function, we see that mapping function we saw yesterday that is made up of what? F of x plus what? Plus that error. Models that tend to have high bias are very simple, and then they underfit the data. So underfitting here simply refers to a situation in machine learning or a problem in machine learning uh, where we have poor inductive learning from the training data, which can always lead to what? Poor generalization. So an example here is, for example, we are using linear regression to solve a non-linear problem. And another example here is what? Ignoring relevant features in a data to build models. If we introduce this kind of problems, then we are going to introduce bias in what? In our model. So another common problem in machine learning is what we call what? Variance. Variance refers to the sensitivity of the model to changes in what? In the training data. So meaning that a model that is too complex can always lead to what we call what? Overfitting. Overfitting in machine learning is just a problem where the model learns the training data too well, including noise and what random fluctuations, instead of just what learning that underlying pattern in the data. Some of the key problems that we move to, some of these real world problems when we'll be building models to check if a model is actually overfitting or not. When we train the model and we are trying to evaluate that model, take for example, you are using the mean squared error as we saw yesterday in a regression problem. If the mean squared error for the training data is lower, while the that for the test and validation set is pretty very high, then there is a high tendency that that model is very complex, and then in that case, that model might be overfitting. So a good example here is using a high degree polynomial regression and also memorizing the training data instead of what just trying to generalize. So the trade-off between variance and bias here is in model error. Bias refers to error of an error from enormous assumptions in the model, while variance is the error introduced due to sensitivity in small fluctuations in the training data, as well as the irreducible error, which is what noise in the data that cannot be eliminated. So always the total error in any model is what we call made up of the bias, the variance, and the irreducible error. So most of the times we are trying to reduce these two terms in our model as much as possible, which is what? Bias and what? And variance. So the visual intuition you should note here is that a model that tends to have high bias and low variance, that model misses the target consistently. By the target here, we mean if you are predicting the house prices, then meaning that that model is not really doing a great job in predicting those house prices. So it can lead to what we call what? Underfitting. Then a model that is having very low bias but high variance, can hit different places widely, meaning that it will always try to do well with the training data, and then when data that it hasn't seen like the test and validation, it might not do well, leading to what we call what? Overfitting. And then what we are trying to look at is what? Try to build models that will have that balance where we have what? A low bias and what? Low variance, so that they can consistently be what? Be accurate. So some of the key ways we can reduce these key terms, bias and variance, is to use the different variations of regression. We already saw regression yesterday. So the different variations of regression that we can use to solve that problem of overfitting is what we call what? The ridge regression and what? And lasso regression. So The standard linear regression, when it overfits the training data, meaning that it has high variance, we can apply. So these two terms where we are using this variation, most of the times in machine learning, we call them what? Regularization, which is a technique which is used to calibrate a machine learning model to penalize large coefficients, thereby reducing that problem of what? Of overfitting. The first one that we are going to look at is what we call the rate regression. In other terms, we call it what? The L2 regularization. Now, we already saw this loss function yesterday, which is the mean squared error. So the rate regression, which is the L2 regularization, is just by doing what? By adding this lambda plus what? The sum of the coefficient or squared to what? To this loss function. So what this term does is that it tries to string some of these large coefficients to be smaller so that it can, make the model less complex and then also reduce the variance or most of those fluctuations in the training data. So we already saw this yesterday. So the only thing we are looking at here is what? This term, which we call it the regularization parameter, which controls for what? For penalty strength. So the effect of this, the L2 regularization is to do what? Is to string coefficients, but does not eliminate them. So it's just trying to string those coefficients to be smaller, thereby penalizing or controlling for what? For the fluctuations in that training data, so that the model might be able to do well with data that it hasn't seen. Also, one thing we should note here is that with this L2 regularization, we can use it to do what? To solve the problem of multicollinearity that I did mention as one of the key problems in regression. Multicollinearity, as we move ahead to some of the real world problems, when we grab a data set, when there is a high correlation between the features in the data set, instead of being between the features and the target variable, then there is a high tendency that we are going to have multiple collinearity in that case. So one way to solve that problem is to do what? To introduce this L2 regularization into our modeling. One other technique we can use to solve these problems of overfitting is what we call the L1 regularization, which is a lasso regression. Here, instead, what we are trying to do here is what? We are just adding the magnitude of the sum of what those coefficients and this parameter. So when this parameter lambda becomes very large, what happens is that some of these parameters will be reduced to exactly what? 0. Some of these parameters will reduce to exactly 0. So if these parameters are reduced to exactly 0, so what are we saying? We can also use this L2 regularization to for what? Future selection, meaning that those features that are not relevant or important in that model or leading to the prediction of whatsoever problem we are trying to solve, like if it was in the case of the house prices, if we were to have number of rooms, we have the size of the house and so on, and then features that are not important will not be included in predicting those house prices. That's why we are saying that we can use this technique to say what? A future selection method. It's also useful when we suspect that only few features are truly important in the model predictions. So the key takeaway here is that for range and lasso regression, when we want to keep all the features in the data, we can use what? The range regression. But if we want to eliminate some of those features, that irrelevant ones, or maybe features that have a lot of noisy data, we can use what? The lasso regression. So also, if we want to use many small and medium features, so we can use the range regression. We only use lasso when we need what? Few features that are very important. I also did mention that range regression can be used to solve the problem of multicollinearity, which is the correlation between the features instead of what? Correlation between what? The features and the target. So another common regularization technique that we are going to have here is what is elastic net, which combines what? It combines the L1 and the L2 now. So this is used especially as we move ahead to tree-based techniques in solving real-world problems. We are going to use this elastic net a lot, which balances between what? Future selection and the shrinkage of those parameters. So understanding between underfitting and overfitting, I decided to create this plot so that we can actually see what I mean by a model underfitting. So we can see here that in this plot, these dotted lines show the actual data. It's like fitting something more like a polynomial. But if we're trying to fit a linear curve here, then that model is going to what? Underfit. Underfitting because we are saying that this problem is non-linear, but we are trying to fit this red line here. So in that case, that model will underfit because it's not actually looking at, is not actually capturing the underlying pattern in this data. Now, overfitting, like in the case of this yellow line, that's the orange line, we can see here that this model is a higher polynomial trying to capture everything in the pattern of this data. So this model might perform very well with the training, but might not perform with unseen data. So a good fit here is just fitting a polynomial like this green line, which actually fits the underlying pattern in this data. So guys, that was it for today. Tomorrow we are going to be grabbing some real world data and then trying to build a linear regression model. So keep following for more, guys. You can subscribe to my YouTube channel. Keep following me on Facebook for more of these tips. Thank you so much and see you tomorrow.